Hi friends, welcome back to the next session where we look at three classic problems of process synchronization. Though the title of the three problems look familiar to our day-to-day life problems, but the problems can be extended to the design of operating systems under process management, mainly when we look for process synchronization and all. So let's get deep into that. So the first problem we look at is what we call a bounded buffer problem. This bounded buffer problem is related with the process called the inter-process communication. Inter-process communication, that means to make sure that the processes do not interfere each other. Every process is given a separate identity, separate memory for all the details of that particular process, and therefore if one process wants to get the information from another process, then it cannot use the memory allocated for other process and all that. So that is not possible. So this is what the basic concept of producing a process was, to make sure that they don't interfere each other. But during some situations we need a communication between the processes, so that's what we call inter-process communication. And to make communication possible between two processes, we have two methods. One which we call message passing, where we pass message from one process to other process via the kernel of the operating system, or we can have a common memory which we call a buffer, a shared memory, shared buffer, which multiple processes can access, and through this we can make the multi-process communication possible through this shared memory. But during this we get different problems like synchronization problem, and in this synchronization problem what we are talking of is we are trying to synchronize two processes. One process which is sending information to the other process. So the one process which is sending information is going to generate the data, and we call it a producer, and the produced data is put it on the shared buffer. So we have one producer that generates the data and writes it on the buffer, and we have another process called consumer that takes this data from the buffer for its further processing. So this way, via shared buffer, the producer sends the data to the consumer process. So that is how communication takes place. But in this we do have a problem of synchronizing these communication. Here the buffer is of a finite size or bounded. Therefore when a producer is writing, then it has got a limitation how much it can write. So there is key issues like there is limited size of the buffer, therefore the producer cannot write more than the size of the buffer. So before writing or before producing the data, the producer should make sure that there is enough space in the buffer to write. Only if there is space in the buffer it should write. If it is not having any free space, then the producer should not write. So that is one thing. That means make sure that there should not be any overflow of the buffer. So this is the problem which should be solved by the producer. So producer should ensure that buffer never gets overflowed. On the other side, the consumer should read only when there is data on the buffer. So when there is no data on the buffer, the consumer should not read it. So we should ensure to avoid buffer underflow. That means the buffer is not empty. So in all, we have to make sure to take care of two issues. One, the producer should not write if the buffer is full. Second, consumer should not read if the buffer is empty. Only these two cases it should take care, and rest again, as discussed earlier, these actions have to be done in atomic version. So therefore we need some mutual exclusion and all that, and that is required to prevent the race conditions. So make sure that two processes do not access the buffer at the same time. So that also should be taken care. So either the producer should be working or the consumer should be working, not both at any given time. So the requirement for the correct solution. So first thing is make sure that only one process works. Therefore you need a mutual exclusion. Only the producer or the consumer should have access to the buffer at any given time. Then there should be a proper synchronization. That means if the buffer is full, then the producer should wait. If the buffer is full, then there is no space for the producer to write. Therefore the producer should wait till some space is emptied. So who is going to empty it? The consumer. So the producer has to wait till the consumer reads it. On the other side, if the buffer is empty, then consumer should wait till producer writes something on that. So what is happening? There is a buffer, producer writes it, consumer reads it, producer writes it, consumer reads it. If this happens at the same pace, may not be a big problem, but this may not happen at the same pace. The producer may do it faster, consumer may read it slower. Then what happens is they keep on piling on the buffer, and after some time buffer gets full. Then there won't be any space left for the producer to write new data. In that case, the producer has to stop producing and writing. Consumer is reading. Okay, so once the consumer reads it, some space is made vacant, then the producer can again continue its work. Other side, if the producer is producing slowly, consumer is consuming at a faster rate, then what happens is the whatever data is available on the buffer goes out faster than what is coming in. Therefore after some time there won't be any data left to read. At that time consumer should wait now. That time the consumer should wait because there is nothing left there. So consumer should be always looking at whether the buffer is empty or not. If it is empty, then consumer should wait. In the same way, the producer should look for whether the buffer is full or not. If it is full, then it should wait. So to check whether buffer is full or not, to check whether the buffer is empty or not, this has to be done at atomic level. Therefore this whole thing has to be made sure that some means is required to do everything in atomic way. Therefore we can make use of semaphores for that. So we need one semaphore to ensure that only one process any given time will access the buffer. That's a mutex, a binary semaphore, which says it is being used or not being used. So mutex is a one semaphore which tells whether buffer is being used or not. If somebody wants to use it, like producer wants to write, so first it should ensure that nobody is reading it or the consumer is not reading it. So to make sure that, just look for the semaphore. What is condition? Is it locked? Not locked? If it is locked, which means that the consumer is using the buffer, so now producer has to wait. That's one issue. If consumer using it, producer should wait. If producer is using it, consumer should wait, because we want only one of them to use the shared buffer at any given time. Mutual exclusion. So we need just a simple binary semaphore to take care of that. Then we need to make sure that the buffer is full or empty. So to know that, we have one semaphore which keeps counting how many slots are empty. Just keep counting how many slots are empty. So this will help us for the producer side. So if any slot is empty, yes, we can write something. If nothing is empty, we can't write. Same way, see how many slots are filled. If any slot is filled, then yes, there is data to be read by the consumer. So one side, producer as well as consumer keep track of whether the shared buffer is available to use or not. The second side, the producer checks, is there any empty slot? If yes, write it. If no, wait. Same way, the consumer verifies, is any data available on the shared buffer? If yes, read it. If no, wait. So that's how we can synchronize all these actions. So one thing, make sure only reading or writing is possible at any given time. Mutex takes care of that. The producer writes only when there is slot available. Empty semaphore will help us in that. Then the consumer will read only when there is something written on the shared buffer. So full semaphore will help that. So let's check that how it is working. So the left side is for the producer, right side is for the consumer. So this keeps on doing. So every now and then the producer wants to write, every now and then the consumer wants to read. So this put in the loop. So before starting anything, the producer makes sure that it is empty. That means at least one slot should be empty. Only then we can write something onto the buffer. If it is empty, then proceed further. If it is not empty, then wait. So wait if it is not empty. That means as long as no slot is empty, wait. If at least one slot is empty, then get in. Once you get in, then wait, look for, is the consumer using that shared buffer? If it is using, then wait. If it is not locked, then get in. So check whether the consumer has locked the semaphore mutex, because mutex is for mutual exclusion. So either producer should work or consumer should work at any given time. So before getting into using the buffer, make sure that consumer is not using it. So for that, check for the mutex, and if mutex is say true, that means other one is using, so wait. If it is false, then other one is not using, then get in. Then you have one empty slot, write the next item onto that buffer, and then don't forget to unlock the semaphore mutex, because now you can allow the consumer to continue because it is now open. The buffer is now open, so say the log is opened, now consumer can use it now. So till you signal mutex, consumer cannot use it. Then you have written one item, that means at least one item is there, so there is something to read. So to tell that, signal full, that means increment the value of signal, and by incrementing the value of full, what will happen is you say that earlier so many slots were full, now one more slot is filled up. If it was empty, then one slot is full now, and so on. So this continues. Same side, the buffer is being watched by consumer. So first thing is, the whole exercise is possible only when there is something on the buffer. So first make sure that there is something on the buffer, therefore just check whether it is full or not. That means at least one slot should be filled up. If none of them is filled up, then wait. Like here, at least one slot should be empty to write, therefore we waited for that. Same way, at least one slot should be written by the producer so that we can read it. So till then, wait. So wait for full. If one slot, at least one slot is written by the producer, then we can read now. So start the process of reading, but make sure that before reading it, confirm that producer is not writing anything on this buffer. So again, make use of the mutex. So mutex is a semaphore which confirms that whether the buffer is being used or not. If it is being used, then it will wait. If it is not being used, it will get in, and it will remove one item from the buffer and use for the next purpose, and then signal mutex, that saying that my work is over, let me unlock this semaphore and leave it open, so next time if producer wants, can use it. And then signal empty, saying that one empty slot is increased because we have removed one item here. So signal empty will increase the number of empty slots by 1, and signal full increases the number of full slots by 1. So when we get a signal full, then full gets incremented, then we have something to read, so we can get in. When we say signal empty, that means one slot is emptied, therefore this wait empty will get a positive response saying that at least one slot is free to enter. So that's how we take care of the three problems. First one, mutual exclusion synchronization, such that either writing or reading is possible at any given time. Second thing, the producer will write onto the buffer only when there is space to write, otherwise you cannot write it. So we must make sure to make the producer to wait till some slot is freed by the consumer, and that is the second synchronization. And the third one, the consumer should be allowed to read only when there is something to read. So it should keep waiting for the producer to write something. If there is nothing to read, then the consumer should wait. So that's how the reading writing activity between two processes can be synchronized using a common memory called shared buffer. So that's it about our first classic problem of synchronization, that is producer consumer problem, which makes use of uh, buffer which has got a finite size. So that's it for now. We have two more examples to look at in the coming sessions. So please don't forget to like, share, and write your comments, and please subscribe to the channel. Thank you.